For the first test, we use a FutureTech FM series microharness tester in order to find the biker's hardest number. As you can see, we follow several steps in order to obtain the result. First, we have to set the machine in 300 gram force. Then we fix the sample in the plate. We use 1018 and 1045 still on the sample. Then we set the microscope and lift up the sample until we see clearly marked and dots in the steel. Then we change the microscope to the Vickers indenter and start a test. The machine lifts up the sample under 15 seconds. It pushes up with a selected force in order to make a mark on it. Finally, we change the indenter to the microscope and then we register the horizontal and vertical dimension of the mark by moving the dials in order to find, as in a vernier tool, the dimension in micrometers. With the horizontal and vertical value, we obtain the mean, and with that we search it on a table. The table was already selected for obtaining the biker's number for a load of 0.3 kilograms force. We repeat the process in order to have a better result. The biker's indenter of the machine should have a standardized size for forces between 0.1 and 1 kilogram, and should have a diamond phase angle of 136 degrees. Now, as you can see in the next formula, the biker's hardest number is obtained by obtaining the sinus of the diamond phase angle divided by 2 times the load in kilograms force times 2 divided by the mean diagonal of impression in millimeters squared.
For the Brinell test, we used a Tinus Olsen machine, wherein we applied a force of 2000 kilograms to the samples. To set up the test, one has to place the sample within reach of the ball by lifting the platform. Then, after making sure the load is accurate, the pin in the top has to be pulled for about 10 seconds. This will push the ball that will make the indentation. Then, we will measure it with a light device that gives a number that is cross-checked with pre-designed charts that give the result. In this case, the given number was 2.7, and after verifying with the applied load, the result was 343 HP. In the Rockwell test, the load is modified with a knob in the side of the machine. Then, the sample is set by lifting the platform, spinning it clockwise until the top of the tester point is within reach of the steel. Once that is done, one needs to make sure it spins 2 more times until the indicator is at 0. It is important to know that the load applied was 150 kilograms. To apply it, you have to pull a lever towards the front and then quickly make sure where the indicator hand stops, because that will be the answer to the hardness test. The black and red scales make difference between the hard and soft metals.
Some samples were subjected to a heat treatment to find out if there was a difference in the hardness results. For this, we used quenching, in which the samples of two different steels, 1045 and 1018, were placed in the oven at 780 degrees, and after 12 hours they will pull out and place in a bucket full of water. Then, to do the inlay, we placed the pieces in the machines with some oil so as to make sure they wouldn't stick, and then pour some resin. Close the chamber and pull the lever until the preload was at 7 pounds force. We had to make sure the load was stable for 10 minutes using the resistor, and then another 5 minutes had to pass with the heat sink. Then we had our pieces ready to be tested. For these samples, we only used the digital version of the Vickers test. After analyzing the results, comparing them to the ones obtained with the non-treated samples, we concluded that tempering increased the toughness of the steel, as can be seen in the results. In metallurgy, quenching is used in steel by introducing martensite, making its crystal structure transform into a much harder one. This gives the steel's characteristics such as resistance to deformation, making it very efficient.